Hello everyone, my name is Priyanka and I welcome you all to my session. Let's read our question. It says that derive an expression for the energy stored in a parallel plate capacitor, and then the next part is a numerical. So let's just do the first part first, that is to derive an expression for the energy stored in a parallel plate capacitor. So for that, let us consider a capacitor of capacitance C with a potential V between the plates. So we can easily say that V is equal to Q by C. That's the relation we are already knowing. Now work done in giving additional charge dQ to C is dW is equal to V into dQ, and then putting the value of V. So we can say that dW is equal to Q by C into dQ. So the total work done, it's simple, we're just going to integrate the two. That is integration of Q by C into dQ. So here work done will be from 0 to the total work done, that is capital W, and then 0 to capital Q. So total work done would be W and C would be constant. So coming out, putting the formula for the integration, it is going to be equal to Q square by 2 and then 0 to Q. Therefore, the answer is going to be equal to 1 by C into Q square by 2. So, the value of the total energy stored or work done is equal to half into Q square by C. Now, we know that Q is equal to CV. Therefore, work done can also be written by half into C square V square upon C. So, one more formula that we get is half CV square. Also, we are knowing that C is equal to Q by V. Therefore, work done again can be written as half into Q square into Q by V. So it is also equal to half QV. So we get three formulas for work done, which is half Q square by C, half CV square, and also half QV. Now let's study or read the next part of the question, which is a numerical but conceptual based. So it says that on charging a parallel plate capacitor to potential V, the spacing between the plates is halved and the dielectric medium of epsilon R is equal to 10 is introduced between the plates without disconnecting the DC source. Explain using suitable expressions how the capacitance, electric field and the energy density of the capacitor change. Now, when the capacitor is getting charged to potential V, D got halved and dielectric constant of K equals to 10 got introduced without disconnecting the DC source. Therefore, remember that the potential remains the same. So now we have to find out the new capacitance. So we are knowing that C is equal to A epsilon naught by D. We have to find C dash now. So here what happened was A was constant, epsilon naught got changed to 10 epsilon naught, that is dielectric of 10 was introduced, and D got halved, right? So we can write it as 20 A epsilon naught by D. So it can be written as 20 C. That means C dash is equal to 20 C now. So it has got multiplied 20 times. Now the next part, that is the electric field. So we know that E is equal to V by D. The potential was the same, however, D got reduced by half. That means it is equal to twice into V by D, that is twice into E. So we can say that E dash is equal to twice of E. the last part of it. We have to find out the energy density U, which is given by half epsilon naught E square. So we have to find U dash half epsilon naught, it got multiplied by 10, so 10 epsilon naught, and then E was 2E the whole square, because we have seen that electrical field got doubled. So half into 10 epsilon naught into 4E square. So we can change our formula as 40 into epsilon naught E square by 2. That means 40 into U. So our U dash is equal to 40 times of the initial energy density. So in such kind of questions, we just have to know the correct formulas and what is getting changed. Just follow a step-by-step procedure and you can easily be able to do it. Thank you so much for your time. Have a great day. Bye.